Let's close out this function with a little graph. Make a graph that is concave down at the point 1, 6. Concave up at the point 9, negative 2. And has an inflection point at 5, 2. Okay, so let's just go through that one at a time. Concave down at 1, 6. That means we're going to be decreasing, in the process of decreasing at 1, 6. So that's what would be happening right there. We have an inflection point at the point 5, 2. So that means at that point we need to go from being accelerating downward to accelerating upwards. So I'm going to stretch this out a tiny little bit. That would look like this. I'm a little bit off, but it would be about right there. We go from being concave down to concave up, so that would make that an inflection point. And we want to be concave up at negative 2, so let me adjust my graph one more time. I'm going to add some more inflection points so that we can get the graph down there. You see, so I kind of just make the graph as we go. Not a big deal. I'll need to add 2 inflection points. So I'll need to be accelerating down and then add another inflection point to be accelerating up. So a little bit silly, but this graph would work. So here we went concave down right here. At this point, we then switched to concave up, which gave me an inflection point right there. Then I had to add 2 more inflection points to get down here so that we could be concave up for that point. So hopefully that's sort of starting to make sense with concavity and inflection points. That finishes out this section. We're going to go ahead and start the next section. I'll see you there.